because it's not digital. You know what I mean? So if you set 20 degrees C here, it will be over there. It might be 19.86 because it's not digital. In the new versions, we have a digital controller now. So it will be, if you type in 20 here, it will be 20 there. But in this version, it was not foreseen. So even if you type in 20, it will be 19.8, or if you go to 100, it will be 99.74 or something. But it doesn't matter for the time. So coming back here again, the program checks if the temperature is just varying between. If you go to 19.8, it's checking if your temperature is between 19.7 and 19.9. It always makes a new mean value here. Mean value, you will see that. It's not running at the moment. And it will check if you are in the certain range between 0.1 plus and 0.1 minus from the mean value.
Is this only when you use the schedule?
It's only when you use the schedule. Because if you do that manual, it does not. Actually, we have that also in the new versions, but in this version we have not been foreseen. Okay. What I would suggest is do something like 5 minutes and 5 minutes, and then go for 1 minute.
This is just for today?
It's just for today. For the normal tests, it would be 15, 10, 10, 10, 10. What you could do for the future, because you use the solar simulator, as I told, the new standard will change, which allows only 2 time steps after this 15 minutes. Yeah, I would recommend it because it's not done anymore. Or you said 15, 10, 10, and then 2 times just a second or something like that. So I would recommend that because that saves a lot of.
No, I don't think
the data is collected and saved?
Sure.
Because they company want to some data, initial data, just to see what it looks like.
Yeah, sure.
Yeah.
But what's not
that final.
what's not collected at the moment is the irradiance, but we will get the irradiance from the scanner later. Okay. So what I will do now is to start use the schedule, and we will go through the other levels then.
Which is the highest temperature that you can?
so. Can I just ask? Here, it's going to spend 1 minute trying to go from 40 to 60.
No. That's what I said. Look here at what do we do for the measurement for the efficiency curve for it. It's you stay 15 minutes at one label at the certain temperature level with a varying temperature of 0.1 degrees Celsius. And then is what I said. You have a lot of material in there, like which has to be heated up, metal, insulation, all the components. And then the standard tells you to take this 15 minutes and throw all the data away.
Right.
Don't collect them. Actually, in the new versions, we don't even collect the data in the 15 minutes. At the moment here, you collect all the data.
But
So
you're going to throw that away.
you can throw that away on your own. So
What's the 15 minutes
that's
total?
No, sorry.
Or is the 15 minutes?
It will
It
be
was
15,
15, but we
10,
changed it to make it
10,
quicker,
Oh,
just for
okay.
our
10.
10.
example.
Right. So we didn't have to wait around.
Yeah, so otherwise we will have the entire day waiting for the test, but we have to do the air collector test in the afternoon.
Fair enough.
So-
Okay. Sorry.
So
Yeah, you can-
okay, and it's going 15, 10. This is the first temperature level, and then it's going 15, 10, 10, 10, 10 on this temperature level. Then it goes to the next level, 40, 144, and it goes 15, 10, 10, 10, 10. Then next temperature level, 15, 10, 10, 10, 10, and then 80, 15, 10, 10, 10. So this is how it always goes, like this: 15, 10, 10, 10, 15, 10, 10, 10, 15, 10, 10, 10.
What's the significance of each division? I mean, you could have just put, what, a total of 55 up here would be the same?
No.
Am I asking irrelevant
Because you
questions?
have to throw away 15 minutes worth
So,
of data.
so the 15 minutes we have to throw away anyway. But I prepared already.
So it's related
I
to
will,
data.
I will go to that as well when we
Keeping it separate.
when we have some more time later. But I can.
This is kind of confusing because each one of these is applied to here.
Yeah, this is
They,
why
they
we,
look like they're lined up, but they're not, are
they're
they?
not.
That's really...
You can change that. That's, you have the open source.
Okay.
Change it if you want.
Space.
Sessions.
As you look at that, you think that's related to that, right?
Yeah, the
That's
first
okay.
thing you think about
Yeah.
is that it's
That's
15
its own
minutes for
window.
20 degrees.
true. That's very subtle, yeah.
What's the highest
That's true.
temperature it can be?
That's true. These two.
110 degrees C inlet. Outlet should not be more than 120. The components are made for 120 degrees C. So if you go for outdoor testing, there are some more variations. We discussed it yesterday, so I have to remember. It's ambient also, which will not change in here. Mass flow, that's the fluid at the inlet of the collector ingredients as well, plus minus 50 watt per square meter is, and the wind speed. So once. That's for outdoor. It's for indoors. It's the same, but they will not vary. The only one which can vary is the mass flow and the temperature. If you look at these, if one of these things vary by more than that, and you collected the first 15 minutes, and then the first 10 minutes, and the second 10 minutes, and you try to collect the third 10 minutes. If one of these things vary, you already connected 2 of the 10 minutes, so you have 2 data points collected already. And then in the third data point, one of these things vary more than it's allowed. Then you have to start with 15 minutes again, and then go for 10 and 10 again. Okay? So, because imagine your collector has heated up for 15 minutes, all the materials are on a certain temperature level, and then you get a big cloud, or it's starting to rain or something like that. Your collector will cool down for everything. So if you start directly with the 10 minutes again, then you will have wrong measurement values because all the materials have to heat up again. Okay? You will see that. Maybe does somebody have a piece of paper? We will see that in the measurement data as well.
In the printer,
So here's time.
Okay. You work for that software now?
I know it's mostly the students.
You go
Take care of the hardware.
up like this, right? And maybe this is already okay for the 15 minutes, right?
Well, we did.
This is it. T in, T collector,
Some of it.
collector in, and then T collector out follows like this.
They're going to decide that for themselves.
So this reaches the maximum a bit later. So this is why, this is why you because it takes time to heat up everything. We will see that in the measurement data as well. So this is why we don't consider all these things and then take these 10 minutes. We will see that in the measurement values.
If you're
Is
measuring,
this a decision interval? Is this where you're making a decision? You divide up this.
it's for efficiency curve.
That's for the efficiency
Oh,
curve.
okay.
You-
Yeah, probably after lunch.
I will go for.
All right.
Sure.
Oh, those are data.
Okay.
That defines where you're taking data. Gotcha. That's all.
No, you gotta sit
Shall
there
I-
and play with it.
Shall I call you later when I have time?
Is that data useful
Yeah,
though?
well, no,
You're getting
Jamie
up to
can come
steady
grab me whenever you
state.
guys get
Isn't that
discussing the
transient
hardware part of
data
it.
Okay.
within here?
Great.
Because what you want is after this period, you want it to be in steady state. Right? That's the goal.
Yeah.
And all the data in between here is. Oh, but you have to take the data to decide if you've been steady. To here, is it?
15 minutes.
After the 50, it might depend on.
After the 50 minutes. You see, this is what I'm.
After
So
the
what is the
50
usefulness of taking data during the 15 minutes? Wouldn't you just check at the end of the 15 minutes to say, are we steady? Or you need it steady during the whole duration?
You
So
need
you're
a
checking-
steady after
check,
after the
check.
whole for the whole
During
duration.
and during, right?
During is not really necessary.
Except that you restart if it's not.
Yeah.
Yeah.
So the past time will indicate if you manage to collect data for 15 minutes.
Yeah.
Is it different if you're testing different collectors, or it's for all water collectors like that?
As I said yesterday, there might be some collectors which have a really big capacity,
Yeah. So
where it
depends
might
on-
be necessary to adjust that to 20 minutes. But you will see that you will see that. So if you automate that, you have no chance. But if you get experience with testing water collectors, you might have an idea saying this collector has steel in it with this thickness. This will take more than 15 minutes for sure to heat the entire collector up.
It doesn't make sense to have these different intervals, does it? Because each one of these is going to run the same amount of time.
Yes.
So you should have the same energy gains. Flow and, well, delta T
Solar.
delta T from here to here at this mass flow requires a certain amount of energy, right? So it should be the same.
Together.
Yeah. So for
Yeah, the different
for collectors
mass flow.
and for if you go for closed loop, if you go for closed loop collector test, you have to add something. So this is not foreseen because the standard is so new. For if you go for closed loop collector testing, air collector testing, you would have to vary the mass flow as well. At 20 degrees, you make 50, 144, and 300. Because I have a presentation on that, because the efficiency of the air collector is depending on the speed of the air which is going through the collector, and the rate, because the Reynolds number, the Reynolds number, if it's a turbulent or a laminar, this is very, very sensitive for air collectors. This is why you measure at 3 points.
So you know everything already.
Okay. I would just start the program and we can discuss more. You just press and use the schedule, and then it will start collecting the data.
And to use the manual control, you just type it in here, or
You just type it in
you don't need
there.
to press any button?
No.
It's kilograms of water.
Is that equivalent to that? Where's the
Divided by average
end temperature of 100?
Huh? What do you mean?
Is this equivalent to this?
No, that's just like setting a temperature and a mass flow.
Okay.
You can
Just
set
one
20 degrees.
single
One.
It
That's
just,
where you want to end up.
it will just stay stable for 10 hours,
Just-
20 hours,
Okay.
as long as you want that.
That's your end point. It's 20.
Can you
Earlier you said that according to the standard, the flow rate should be 0.002 kilograms. Is it per hour per square meter
Per
or
second.
per second?
Per second per
Yeah,
square
okay,
meter.
because here it's 142. That's what I was.
Yeah, that's per second per square meter.
I spend
Okay.
more time with cameras and pictures here than I ever. Is that recording too?
So
Yes, pretty good.
You're a pain in the neck.
schedule is just for changing the temperature.
Automatically.
But you must, when you gather the data, you find those points manually yourself based on the time. It doesn't indicate off there.
Now, actually,
Oh, is
in
it?
the new version, yes, but in this version we have now.
So you have to take a look and see where it changes.
No, yeah.
Is it on? Is it running?
Afterwards for-
Oh, okay.
Make a note or something to know where it changed. So
Yeah. So it will be. You will see if you collect the data, you will see that actually.
yeah,
And
you see
what,
that.
what we do in the newer version is only in the end you just get 1 point. The average value of 10 minutes. And then it says 20.3 degrees Celsius, 144.3 kilogram per hour, and then you can just and then 4 times. One is maybe 123.1 and one is 143.7. That's in the new version, but you have to do that on your own.
The new version of the software, or
Yeah, the new version of the software, but it's not.
would it work with this simulator?
No, it's because you have different data acquisition unit, different control unit, more sensors, so this would not work. So it will take 3 or 4 days to adjust that. Maybe I can ask Andreas if he has some money for us.
Probably have to install new version of the
You have to
lab
Yeah,
pay
we
them.
have new LabVIEW version, so you need a new LabVIEW version. We have a different controller. So if Andreas has money for 4 days of working for that, we can change that for you.
Hire the program.
I can ask him. So, or if you need that once, I don't know how often you will test water collectors. So he wanted me to test that with you.
Well, we can just manually enter data slowly, you know.
So
Yes, we will just every time you walk.
We are doing research.
Kind
We do not really want turnkey testing platform.
yeah, so
We want to discover problems. Not to let it run
It would be
smoothly.
nice to solve them too,
Create
but
problems.
you know.
Well, it's so smooth. What student is here
Okay.
for?
What we do is we make problems.
So maybe we go to here. Okay. Here's that's for the controller. I guess you will never really use that. But here's a configuration window for the Agilent. The Agilent is a data acquisition unit. It's saying we have water. We have 2 possibilities. I already indicated that in the beginning. We have water and we have. I should use that one over there. So
Just use mouse pointer.
So
No, give him a stick.
So we have sensors for water measurements and we have sensors for air measurements. I use that one.
If you need.
We have some temperature sensors in there, 4-wire resistant temperature sensors, which are on the channels 101 to 1006. If you would, there are some more for the air collector, but I don't collect the data. So if you would like to install some new ones, you could also type in 101 to 110, or you can make a comma 1012 or something like that. Or this is for resistance. Here's also 0 to 10 volt. If you want to add a sensor for 0 to 10 volt, you can do that over there. will not be displayed in here, for example, but it will collect the data. If you want to display that, we can also display that because you have the source code. But for standard-wise, it will not be. Yeah. As we are on water collector testing, these figures will always be 0. So we have also 0 to 1 volt signals, that's pyranometer. This one is wind sensor, I guess that's pyranometer and solar cell. With a 2-wire resistance, that's the resistance for the measurement of the current is the mass flow meter, and thermocouples I think is not because we don't have a card.
That's why it's 200.
So these are those PT
100. Okay. So this one is
good one.
Number 1.
I'm going
for
It's Andres here today. You see?
So here's a data acquisition.
You're going Tuesday, right? Just for Tuesday?
Tuesday and Wednesday.
Right. Sorry. I mean, for the conference, just Tuesday.
And
Yeah,
over
I'll be
here,
probably there Monday and Tuesday.
you can see that you have the PT100 on channel number 1, which is channel number 1 here, 1001, is the inlet of the collector. Number 2 would be the outlet of the collector. Number 3 is the mass flow. Number 4 is the ambient. Number 5 is the ventilation head. Number 6 is the ventilation right. 7 would be air collector inlet. 8 would be air collector outlet. 9 would be mass flow of the air. 10 is the heat exchanger out. There's a heat exchanger for the air collector circuit. So this would be the heat exchanger out. So you see these are all 4-wire connectors, connections. Here's the one, just a 2-wire. This is why we have 2-wire connections for 1011. And then on channel 12, I have to see let's read it like 7, G11, it means 7, G11. So this is the humidity and temperature of the air.
This number, the 1011, is related with the number of like
it's channel 11. This one. And channel 10 would be this over here, 4-wire resistance.
So, so to say 10, it's nothing, so only
No,
11,
10 means
Channel in the Agilent.
yeah, we have 8. I think we have 8 slots, and 0, 1 means it's the first slot where it is installed.
8, you can believe. 8 these
I think there are 8 slots that are available, but we just connected 1.
2 or 4 wires, it depends on.
4-wire is more accurate. What you have, if you have a wire, this has so you measure the resistance, right? Or you determine the resistance of this, and by having the resistance, you can calculate the temperature. So at 0 degree, it has about 100 ohm. You say ohm?
Yeah.
You have about 100 ohm. So, but if you have a wire, this has a resistance as well. If you just have a 2-wire PT100 sensor, it will also consider the resistance of the wire. If you have a 4-wire one, the Agilent is able to determine the resistance of the wire separately
that out.
and take that.
So I imagine one pair has nothing on it and measures the resistance of the wire.
Yeah,
the other pair has the sensor and the resistance and subtracts the two to give you just the.
somehow like
Because the way it reads, it's a 10 megohm.
yes.
And you cannot measure the resistance with 10 megohm. So you supply a voltage, and then with the 10 megohm, you measure the resistance. 10 megohms to battery.
Oh, that would be on one of the other two.
Yeah, one supplies the voltage, the other one
Okay, you go back.
voltage across the resistor. And then you can determine the resistance.
I think the battery
So
is
this is
gone.
why you also need 4 channels then. So
So it's basically,
2 channels.
roughly, it's more accurate.
That's more
More-
accurate.
It's more accurate sensor.
It generates a constant current, like a 0.1